Hello there, Joe Shaw here, Incubation Engineering Department. I'm a full stack engineer for the Application Performance Monitoring and Management solution. So this is our weekly demo issue where I put in what I've been doing for the week and add my recording into. You can follow the link here to the container issue where you can subscribe to weekly demos. So, following on from what we were doing last week, we're trying to get a test environment with automated deployments through so that we can get a staging environment together with a good sort of hardened implementation with Clickhouse and the gateway in so that we can get through the hurdles of getting that into production as well, because there's a certain amount of rigor required for that in GitLab, which is good, of course. So I've been looking at how we set up Clickhouse generally, so things like authentication, security, also replication and sharding. So in terms of replication, you can see that there are replicated tables that you can build into Clickhouse, and that's what we've started doing now. These replicated tables require Zookeeper to be installed along with Clickhouse so that the replicas in Clickhouse communicate the shared state, such as tables that should exist in the cluster through Clickhouse, and you then have to define a relative sort of path within Clickhouse, well, actually an absolute path in Clickhouse here. So this is an example where it stores like the shard information for that replica, and you have to do that within within Clickhouse to make that work. So what we've also been looking at as well as creating the replicated tables which exist on each replica, you can also use this distributed table engine to create a sort of abstraction on top of those tables that allow us to just operate on the distributed table rather than having to synchronize and query into individual replicas. And this makes it really useful. And makes it easier to query against. So that has a slightly different syntax. So I'll show you that what we've got here. So I'll get onto this shortly, but in terms of migrations and things, there's an example of what you might call a local replicated table. So it's created on a specific cluster using a replicated merge tree, and that would be replicated across each replica in that cluster. And then we can create also a distributed table engine, which sort of mirrors that metric local table and allows us to span queries across those tables. So that's really useful. So then all we have to do is query this one metrics table rather than distribute queries across all the replicas manually. So to help us do that, the alternative Clickhouse operator that we've been using provides macros, which can be defined as part of Clickhouse's configuration. And it manages those. So as you increase the number of replicas or shards, this Clickhouse operator then manages these macros so that whenever you're creating a table that's local, these are expanded to the correct values, so then you don't have to go and put config in for each single replica. It handles all that nicely. So you can see an example here of creating a replicated table, and this is a path, a Zookeeper path that defines that table. So it makes it specific to the installation, to the cluster we're running in, to the specific shard database of the table, and the name of the replica. So that works, and then we can create the distributed table on top of that, and we do that with ours as well. Notice, however, that within ours, in that creation there, we don't actually have to specify those paths because we've configured a set of default properties for our Clickhouse installation so that we don't have to keep repeating those same keys over and over again. And you can see that if we have a look at the values file, so we're deploying all this through Helm, have a look at the values file here. In the Clickhouse section, we've got this extra defaults XML file here that gets merged in, and you've got that default replica path you can see there that will get used for any replicated tables. And the default replica name, again, it's a macro that will get expanded depending on which node you're on. So the other element of this, which is important to get working as well, is migrations. And I will just say before I move on to migrations, we are not worrying too much about sharding at the moment. Sharding is kind of necessary when the amount of data we've got outgrows a particular server. I don't really need to worry about that just now. It's something I need to monitor, obviously. But replication is useful because it effectively gives you stability. You've got effectively a backup running in the cluster there. If anything goes down, then you could load balance onto the other server and things like that. So that's useful. So the other thing we've been doing is, as well as getting that working, is working out how we do database migrations with Clickhouse. Again, it's important to have migrations in place because we don't want to have to go into any environment and manually run scripts against databases to upgrade them and things like that. It's not very good practice, and ideally we want a sort of seamless upgrade, so whenever we upgrade via the Helm chart, the migrations get run and the application keeps working. So Clickhouse, it doesn't have as a sort of mature migrations and management community as, say, Postgres would do. And in GitLab, we already use the Rails migrations system to migrate the database, and there's a lot of work gone into that, and it's very mature, but it's not really applicable to what we're doing here. We need our own strategy. So we've picked up this tool called Go Migrate, which is, I've seen some various recommendations for. It's both a CLI and a library written in Go that will do database migrations for you. So it will have support a number of different migration sources, as you can see here. So we're just using file system sources. Our migrations get stored in a config map to go in with the release. And you can see you've got basic CLI usage there. So we're, path to the migrations, point at a database, and you can bring them up. Likewise, you can roll them back. And that's proved successful. It's taken a little bit of time to get that working. So as part of the branch we're working on, we've got the migration strategy documented here as well, with some links to the various things we're using. The migrations have a particular format name, so they've got a date time stamp in there, so that if there are multiple people working on it, they shouldn't clash, for example. And I showed you an example of some of those there that we could see in this project. So, for example, you've got the creating the distributed table there. You also got the down migration for that as well, which drops the table on the cluster. And we've got some tests for those as well. We're going to put in continuous integration that will, every time we push, we'll do a full up and down migration to test that it all hangs together. So the way that we actually get these migrations working is via Helm hooks. So in here, there's a brief description of how that works. So on install, we use a post-install hook to run the migrations. On upgrade, we use a pre-upgrade hook to run effectively the same script. So whenever we are rolling out a new version of this Helm chart, we'll get the latest set of migrations baked into it. So we effectively just copy them into the chart. So the problem here is that the rollback migration didn't work as I expected. And long story short, I had to kind of put some, be quite inventive about how that should work. So effectively, each time we run a migration, we get a revision config map in the solution that stores pointers to where we migrated from and to. And then if we do a down migration, we can automatically pick that up in the cluster, perform a down migration, then remove that because it's no longer valid state for the cluster that we're working in and the state. And then we can effectively branch in a different direction if the migrations take us that way. And that was a bit awkward to work out. I was hoping I'd be able to use rollbacks in a much simpler way, but unfortunately it's not implemented that way, and there are a couple of issues around that have been created. So I'll just do a quick demo of that. So using scaffold to run against our local cluster. So let's just do a run there. And if I open K9s here, you'll start seeing the pods coming up. There's the Clickhouse cluster highlighted there that's coming up, and various services that are starting as that cluster comes into existence. One of them is the migrations here. So that runs, it's getting a crash loop back off initially because the host doesn't exist, but fortunately we're in Kubernetes, so it handles that nicely, and it's going to do a number of restarts until it can connect to the cluster and run the migration. And you can see various things are coming online. Our cluster is there and running. Let me just show you the sort of config maps that go into building that Clickhouse cluster. So one thing here, not this one, maybe, not that one, there we go. This is the actual cluster specific, the replica specific config file. As I was telling you earlier, you can see those macros in this part here that have been set up that are specific to that replica. So you see replica identification values there, the shard, the actual name of the replica there, for example, and the zookeeper that we've connected it to. So if we go back to the pods, we should see that now that on the third attempt there, the migration worked. Let's have a look at the logs. There you go. So we didn't find any migrations, and it ran them all, and there you got it migrated to that particular one. If we look back at the config maps, this is the one that we'll be looking at, and this is a config map that was saved that says it migrated from nothing, which it didn't because it was an install, and then it migrated to the specific version. And if we were to do subsequent migrations, we get more of these config files with those bits of metadata in. And I've tested it a few times, and that seems to do the job. So that's quite useful. So what else is there? A couple of useful links that a few people had pointed me to. First of all, there's a Jaeger Clickhouse plugin for storage. So I will have a look at this at some point. It's got a schema definition for storing spans and traces in for traces for the Jaeger interface. So that looks useful. Another one is this vector project by Datadog, and I've been having a look at this as well. This looks like quite an interesting way of building data pipelines for observability data. So I think you can think of this as sort of like FluentD, whereas that's just looking at log data. This is looking at sort of any sort of observability data with a very pluggable infrastructure. So there are lots of different source data, sources, transformation mechanisms, syncs, and of course, as part of the syncs there, you've got things like Datadog metrics, for example. So if anyone were using this, they could, in theory, put our endpoint in here for the configuration and ship metrics from different systems into our system, which is great. So that's a very interesting project. Okay, up next, I'm going to continue trying to get this testing infrastructure working and into a test environment before I get it into a staging and hopefully a production environment before long. So I'll continue iterating on that. Okay, and that's all from me. Goodbye.